Vertical asymptotes. The line x equal to a is a vertical asymptote of the graph of a function f if f of x increases or decreases without bound as x approaches a. Look at an example. You can see here as x approaches a from the left, our y value is increasing without bound as it goes to positive infinity. So we can say as x approaches a from the left, f of x is approaching positive infinity. If f of x is equal to p of x over q of x is a rational function in which p of x, the numerator, and q of x, the denominator, have no common factors, and a is a zero of q of x, the denominator, then x equal to a is a vertical asymptote of the graph of f. Let's look at another example here. We have x is divided by the quantity x plus 3 times the quantity x minus 3. So what we can do is we can look and make sure that there are no common factors between the numerator and denominator, and in this case we have none, so we can continue. What we can do is we take our denominator, x plus 3 times x minus 3, and set it equal to 0. And since it's already in factored form, we can take and separate each factor by setting it equal to 0 and solving it. So what I've done is I've taken x plus 3 equal to 0 and x minus 3 equal to 0. And now I'm going to solve. So the first factor we can say that x equals negative 3, and the second factor I can say x equals positive 3. Well, what we have done is we have created the equations for our vertical asymptotes. So in this case, I can say that I have two vertical asymptotes, one being x equal to negative 3 and one being x equal to positive 3. So if I look at the graph of this function, I'll notice that there are two asymptotes in which my graph never crosses, one being x equal to negative 3 and one being x equal to positive 3.